Hello everyone and welcome to this presentation about knowledge graphs. Just to start off by introducing myself. My name is Joakim Nilsson and I'm working as a data engineering consultant for Capgemini in Sweden. And my primary focus has been on graph technologies and knowledge graphs. And I have an educational background within mathematics with a bachelor and master's degree. And I am located in Malmö, Sweden. So, why should we care about knowledge graphs? Gartner has identified graph technologies as the game changer for companies looking to integrate and automate data and processes. And they think that more than 80% of such projects will depend on graph capabilities by the year 2025, which is not that far away. And they are highlighting 4 unique capabilities that are setting this technology apart, being capturing business knowledge, data discovery and usage, answering complex business questions, and efficient AI. And this is a chart that I like and I think it's quite interesting, where Gartner is predicting the future technologies, the time frame, and also how big of an impact they will have. And we can see in the upper right corner knowledge graphs laying within the 1 to 3 year time frame. So it is a good time to get familiarized with this concept. Now, when we are talking about graphs, as in knowledge graphs or graph technology, we are not talking about the type of graphs that you might remember from your mathematics courses with the x and y axis. Instead, when we're talking about knowledge graphs, we're talking about something like this. Now here, this is a very simple example, but we can see in this graph how the person Bob is linked to the city of Paris. Firstly, by his interest in the painting Mona Lisa, that is at the Louvre Museum, which is located in the city of Paris. He is also linked to Paris by his friend Alice, who visited the Eiffel Tower, which is located in Paris, but it's a longer route. And some definitions. In a knowledge graph, it is made up by nodes and edges, where nodes represent entities. It can be persons, companies, organizations, objects, and edges represent the relationships between these nodes. And to tell the nodes apart, we use something called URIs, or unique resource identifiers. It also worked with explicit and implicit knowledge, where explicit knowledge is knowledge that we already know and we map out, and implicit knowledge is something that we can later deduct from this knowledge graph. And we're also working with SPO triples, which is subject, object, and predicate, which is depicted below, where 2 nodes are connected by relationship, and this forms what we call a fact. So in this case, A is somehow related to C by the relationship B. So what is a knowledge graph? Knowledge graph allows an organization to focus on what is important in data, which is relations. And in a knowledge graph, we treat relations as important as the data points itself. So the relationship between each of these data points. And knowledge graphs can represent large amount of data in graphs, which is a more natural and intuitive way of thinking about data that are interconnected. And to the right, you can see how we store data in a knowledge graph is not how it's stored traditionally in a relationship database with rows and columns. Instead, it's stored as nodes in a graph. and this is more intuitive, and it allows for very fast querying and traversing through the graph. Relations are fundamental and easily accessed in a knowledge graph, thus making it superior in working with relational data types. It's easier to visualize it and inspect it. It also allows for reasoning of the deeper meaning of the graph, both for humans and machines. Now, knowledge graphs and graph technology relies on mathematics, and especially an area of mathematics called graph theory, invented by a Swiss mathematician, Leonhard Euler. And it was invented during a very famous example of a mathematical problem called the 7 bridges of Königsberg. So the problem was to figure out if there is a way that you can cross each of these 7 bridges once and only once, and you cannot cross the river in any other way. And to solve this problem, Euler developed a concept that later turned into this graph theory. Now, the structure of a graph. So a graph can be directed or undirected. An example of a directed graph can be a LinkedIn follower. I can follow you, but you don't have to follow me back. Whereas an undirected relationship would be a LinkedIn connection. There's no way that I can be connected with you unless you are connected with me back. And the graphs can also be homogeneous or heterogeneous. So it depends on the relationship. We can map out different types of relationships. So you may have one type that is similar towards a coworker, but a different kind of relationship towards a manager and an employee. A graph can be weighted or unweighted. So we can put emphasis on the nodes, the importance of the nodes by putting weights on them. And this is done, for example, in academia for citations, where it is more, it weighs heavier if a famous professor cites your work than if a bachelor student is citing it for his thesis, for example. So one very famous example of the use of a knowledge graph was in 2016, a case I think many remember, in the Panama Papers. So what happened was that it was a leak at a huge law firm working with tax havens and tax evasions. And the journalist that received this leak deemed the amount of documents was so vast that they needed to another way to go through it than just read it manually. So they decided to build a knowledge graph. And this knowledge graph turned out to have more than 840,000 nodes and 1.3 million relationships. And throughout this knowledge graph, they could identify over 200,000 companies in 21 tax havens. And they could identify world leaders and oligarchs, sports stars, and celebrities that have been trying to evade taxes. Another area where we can use graph technology is within contextual AI. And by doing so, we can enhance the contextual understanding of the AI. We can also improve reasoning and inference capabilities, also better explain and interpret the AI. And this combined will make the AI more reliable. Some use cases, among others, there are many use cases for knowledge graphs. Some are within finance for fraud detection, also in the medical industry for developing new drugs. Search engines like Google has arguably the most famous knowledge graph, and also within retail supply chains. So when should you use a knowledge graph? Well, you can use a knowledge graph when you have many solutions and different data sets at different places in the organization. When you want to do a faster journey towards becoming a data and insights-driven organization, or when you are interested in the underlying relationships within your data. If this sounds interesting, then don't hesitate to reach out to me. You can find me on LinkedIn. And if you want to know more about knowledge graphs, then don't miss my colleague Veronica's talk after the lunch. Thank you.